Good afternoon, everyone, and welcome to Improving's Virtual Lunch and Learn. Before we start, please take note of the question mark icon at the upper right corner of the presentation screen. Clicking that icon will open the question and answer feature, which allows you to send questions to me, our moderator. Your questions will be delivered to our presenter at the appropriate time. We are excited to present David Lewis, Principal Consultant at Improving, who will be sharing Crawling Out of the Mud from Monolith to Microservices. David, take it away.
Hi, everybody. Welcome to my talk. Here's a little bit about me. Feel free to contact me on any of these ways, and I'd be glad to hear from you, especially if you have any feedback on this presentation. So our theme today is crawling out of the mud, and so of course the mud is referring to the big ball of mud. And so this little guy here is a mud puppy. He'll this adorable little water dwelling, mud dwelling thing is gonna take us through it. And so we're going from Monolith here to microservices. So I built this talk around a couple of themes, and one of them is this little poem. And so, the time has come, the walrus said, to talk of many things, of shoes and ships and sealing wax, of cabbages and kings. So what I like about this, and I think the really salient point of it is there is none of these subjects that are more important in this context than any other. So ships and sealing wax, without the wax, the ships would rot. Cabbages and kings, if population isn't fed, then the king is deposed. So these little things, these things that seem insignificant, stand up against these things that seem grand. And so and are essential to them. Are essential for them to be able to exist, at least for any meaningful amount of time. And so the themes we're going to cover here is the big ball of mud, microsurgery starting at the finish line, on silver bullets and golden hammers, data everywhere, friends, enemies, and frenemies. Everything is a protocol to someone. And so each one of these themes is going to bleed into the next. And so I may be mentioning some things in one and then expanding on them in another one. So as I'm talking, though, I would like you to ask questions if and there's a little bit of a delay before I will get them. And so at the end of each section, I'll pause briefly, and the producer here, Will Hausman, is going to read off some questions to me. And if I'm intending to answer them later on in the presentation, I'll just give a little shout out to that, or answer them obviously right out. So the big ball of mud. So it started out harmless, small and perfect, exactly what you needed. And here's a shiny, nice ball of mud here that's perfect, exactly what you needed. And so these things never stay the same. The business isn't static, and neither is your system. And so you're going to get some emails. No worries, you can fix this. Just a bit here and a bit there. You're just adding to it. It's not a problem. Then marketing called. They had some features that they really think are important. And so at this point, you're going, well, people aren't supposed to be happy at work anyway. It's only 30 more years till retirement. I can stick this out. I'm tough as this individual is. So really where our story starts is here. Things have gotten out of hand. You've got maybe periodic outages because you know, your system isn't designed for the business as it is today. You designed it for what it was, and then you tacked on a bunch of stuff as part of a, natural evolution of your system as the business's needs evolved. And so, some things to remember about this. Every big company was once a small company with a software architecture just like yours. Most companies start out with a simple n-tier system that just fills some need that the business has, and then it grows. And so as that growth happens, your baby grows up. The actual data requirements happen. The number of domains that maybe your simple system once covered can balloon out. And so remember, growth is a good thing, and you're really just a victim of your success here. Take a few minutes to enjoy this. Clap yourself on the back. You have a lot of work left to do, though, to sustain growth, so don't take too long. So here's our big ball of mud. I put a lovely flower at the top here. So we're going to get a little bit more abstract about this, and so we're going to call this legacy. So legacy really can't stand on its own, because this is the thing that we're looking to start taking functionality out of and move into microservices. And so the way we do that is we recognize broadly what these domain boundaries are within the legacy system, and we start standing up an anti-corruption layer. An anti-corruption layer is really a service, just like every other microservice. This one just happens to be broadly represent your legacy system, and so it will take changes from your legacy system and send them out onto an event bus. That will then be, those events will then be consumed from a queue into your individual microservices that you're starting to move that domain logic into. So this anti-corruption layer is a little too long. We'll probably just call it an ACL, and we'll kind of focus on down to what that ACL actually is. And so you're going to have if you're lucky, you have an existing legacy service like an API layer that you can hook into, and so whatever changes are pushed into your API layer, you then trigger an event message with that change into your microservices, into your event bus. So if you're not lucky, if you designed your system as essentially like a front end or a PHP layer or a MVC or web forms type layer over top of a database that contains all of your business logic in the form of stored procedures, you're not done yet, but it's not an ideal situation. So what you can do in those situations is you can lean on a technology called change data capture, CDC for short. So change data capture you can register individual tables, and that will create a CDC table that records every transaction along with a transaction number that happens in that subscribed table, and that will become an individual record on that. And so what you do is you just record a high watermark. Initially, it's going to be 0 for that transaction identifier, and then you'll send out any records that are in that CDC table that are in a higher numerically, and then you transmit those out to your event bus, and then you record your high watermark, and then you do it again. So anything higher than that previous high watermark is going to be. I'm sorry, I'm having some technical difficulties here. Give me 1 second.
David, would you like to switch back to just presentation mode?
Yeah, hold on 1 second, and I will get this stuff. All right. Sorry about that. I've got this. All right. Is everything showing up correctly for you?
You are back at Microsurgery.
All right. All right. Let me get this resolved here. So I'm looking in the right direction. Okay. Sorry about that. All right. So. And here we are. Excuse that, a little bit of a technical problem. One of my monitor has lost signal, so I couldn't see what I was doing. So, all right. Let's see. And my okay. Okay, there we are. All right. So change.capture allows us to turn these individual changes in your database into events. And so if you have to resort to this, it is an option available to you. CDC is available in really all major database platforms. So if you're using SQL Server, MySQL, Postgres, this is an option available for you. And there's actually some great great tools that you can use to enable this as well. All right, so back to where we were. Okay, so your ACL is going to be communicating with your microservices, and specifically, it's going to be communicating via events. And so these little small documents that the ACL is going to send out. Initially, you know, you may not have a high degree of integration between the first services you start standing up. Just know that this is going to change, and the role of your ACL is going to evolve throughout as your system starts to evolve as well. So as this happens, you're going to start standing up new services, and they're going to start exchanging events between one another. So what we were looking at was a logical diagram representing the microservices. What's here is the actual physical structure. So the ACL is just going to be talking to an event bus. It's going to be publishing messages, and microservices are similarly going to be publishing messages onto the event bus, and receiving individual events from the event bus. So the logical layout obviously has individual microservices talking to one another. In reality, they are all talking to the bus and are all receiving events from the bus. All right, so we see something here that most of these communications are via events. You're going to run into individuals circumstances where this is not an appropriate pattern. There's one really that I've ever run across, and it's around authentication. So it's difficult to authenticate a user asynchronously. So it's probably better to just verify a user's identity early on in the process, and issue a token in that for handling that. So in this case, I allowed for that that one call response link between two of these services. So we're going to get to this in a little bit, but this is something to be aware of, that you may not be able to have a perfectly pure event-driven system. So we're going to kind of zoom in a little bit on a set of messages, a set of events that are flowing through this bus. And the important thing about an event is something that you probably intuit already. Events always happen in the past, and so time is a factor. As time flows through your system, as events happen and awareness of events propagate. There are multiple ways to manage that that feature of microservices, and we'll cover that a little bit later. So zooming in on one of these sets of events. So initially, you could maybe this is an invoicing service, and maybe it's got to know about invoices and line items and billing and pricing and that sort of thing. So this is a with all of these things that it has to worry about. This is a pretty big microservice. So something to keep in mind that when you're initially starting to stand up these services, if you try and simplify them and start to break them apart too quickly, you can run into a situation where you're reducing the complexity in your microservices because they capture a very small domain that is very focused, which is a good thing, and that is the goal. But while you're relying on your ACL, the complexity of that mapping between your legacy system and your microservices is going to go up as your design drifts further away from that legacy. So initially, it might actually make sense to make some larger microservices. With the knowledge that the goal is to break those large microservices, these mini monoliths, up into actual microservices that capture a very focused domain. So, like I said, as the complexity of your microservices goes down, the complexity of your mapping is likely to go up, and similarly, as your microservice complexity goes up, which is to say it matches the original design of the monolith more within a limited domain. The complexity of your ACL, your mapping layer, is going to actually decrease. So I'm not going to say that you should make great big initial microservices, but it's something to be aware of, that when you're planning these things out, deviation from the current like structures can have a cost in complexity with your mapping, and that mapping is really, over time, it's going to go up in complexity. And that's a good thing, because as your microservices start coming online, that mapping will go up, and at some point it will plateau, and then as you start decommissioning legacy parts of your legacy system, removing them from active use, then that complexity can come down, because you don't actually need that mapping anymore, because your microservice is taking over that role. So here we are back to our system, and then we're going to go ahead and transition to starting at the finish line. Will, is there any questions that the audience has?
Not at this time.
Okay, so like I was just saying, you don't want to start at the finish line necessarily. It's difficult to see what the future holds, and really, what you want is to start down the road, and then as your teams start to evolve and start to learn new skills, then you can start to apply those into more and more meaningful changes within your microservices architecture. So every structural change is a complex mapping. Keep your ACL simple initially. Don't let your domains deviate too far from the legacy, at least not yet. And so that not yet is an important part of this. So you may initially stand up a microservice, your first one, and it may have many roles. It may do many things. And obviously a microservice has to have its own storage. Because it is a microservice, it has to be isolated for it to be stable. So eventually, you may start breaking up that mini monolith into smaller, more focused microservices. And so what was invoicing and billing and pricing may become an invoicing domain that really only has to deal with taking in consuming the information that pricing publishes out, as well as putting together any billable sales into a report that can be used as to send out an invoice. So you can start thinking of this what was your previous service as just a part of your ACL, and so you can just start subsuming those initial services back into the ACL, because what they become is simply a mapping layer. So fairly short section. If there's any questions, I can take them now. And
still good.
They're still good. All right. So two great things that go spectacularly together. So this is golden hammers and silver bullets. So there are a lot of experts in our field, and they don't always agree on every single thing. And sometimes a technology or an approach is a good one, is a solid one, but your teams are not yet ready for them. And so there's a educational slope you're going to have to climb. And so different individuals arrive at certain points conceptually sooner than others. Sometimes some aspects will stick with one developer, and other aspects of this sort of system will really gel with another, and they may disagree then. So keep in mind that you will have disagreements, and don't be dogmatic about it. So remember, as your systems start to evolve, your teams are going to start to evolve as well. And there's a whole history of this system structure and application structure that you can call on. Conway was a very self-aware individual. So that would be Conway's law. And so a few things we've covered so far, indirectly at this point, but I'd like to kind of formalize a little bit. So we talked a little bit about the domain, and so domain would be representing the essential complexity of your system. Everything that the business needs is covered by the domain, and obviously in the real world, that's not all of the code you write, and so everything else that is outside of that domain is what you would call incidental complexity. And so that incidental complexity is the nods you have to make towards the structures of your communications pipelines, or the things you have to do around just managing deployments and application lifetime. So that incidental complexity and essential complexity is in a microservices system, the essential complexity should be larger relative to the incidental complexity in that service, and so it should be easier for an individual developer to understand, and things like a single Scrum team of 5 people could create and complete a new microservice within a relatively short amount of time once they kind of get into the swing of this thing, or at the very least make meaningful changes to a microservice within the span of a sprint. So that's one of the major advantages, is because these things are smaller, they're much easier to understand, and because they're focused, their relative essential complexity to incidental complexity is leaning heavily towards essential. So global complexity and local complexity, and so in a microservices architecture, the local complexity is actually reduced because there's literally less code for you to have to deal with. Global complexity is another thing, and so in microservices you may start to become aware, because you're dealing with many services that are interacting in various ways. You might have to give some thought into how your failure modes are going to operate, and so we'll cover a little bit of that later, but things like dead letter queues and error queues are pretty important, and automating how you handle those situations is also going to be very important. So a little bit about scalability. So vertical scalability and horizontal scalability. Vertical scalability is probably what you've been doing all along. Your application gets slow, so you move it to a bigger and faster machine. Your data volume has increased because you're getting more customers, because you do a good job. So you have to upgrade your SAN, get bigger hard drives, or get better servers that have a higher data throughput. And so there is a limit to vertical scalability. So you're going to hit technical and technological limits pretty early on, and once you start pulling in different domains, and if they're primarily connected through table to table type stored procedure type operations, or if they're connected to one another through function calls between domains that are hosted in the same application, you're going to start hitting some really fundamental limits on table locks and that sort of thing. So horizontal scalability is really what microservices bring to the table. So we're gonna scale horizontally. We're gonna take portions of that data and host it in its own isolated database, and then you're going to be able to stand up as many processes as you like to talk to that. And in situations where your data volume has grown, this is a good problem to have, because if your data volume has grown to the point where you have to do something like sharding to isolate portions of your data and individual microservices that cover the same domain, so that your databases can handle the data volume, or however you store your data. It may well be schemaless architecture, but either way, microservices kind of give us these options. Very difficult to do sharding in a n-tier system that covers more than one domain. So this becomes options for you, and the cloud becomes becomes your new playground potentially. So the final thing here is it's not really a spectrum here. So scalability in this case equals redundancy. So as your microservices start building out, obviously, because the links between your services, because you're a disciplined engineer, the links between your services are all asynchronously event driven. that means that that for something to happen in a a real time. So for example, if your clients are going to make a purchase from their shopping cart, the thing that actually handles that purchase has to know somewhat what the state of that shopping cart is. It has to at the very least know what the total purchase value is. So that shopping cart will be publishing out events related to its internal state, and the purchasing system should have that event available to it when it's time to make that finalize that sale. So if your client got all the way to the end of the transaction, is ready to pay, and say for example your inventory system goes offline, you already know the state of the shopping cart, you already know the state of the purchase, you can just push through that transaction, and because you're queuing up these events as they're generated. When your inventory system comes back online, it consumes all of those completed sales, and docks your inventory, and maybe even schedules new orders, which is something that your microservices can actually start to take on, because they're not bound up into a single executing thread or into a single database. So some important points to talk about here. Platform uniformity. You're going to need a team for that. So a lot of times, containerization and microservices are spoken of in the same breath. So the reason for this is, as you start, if you've got a single end tier system, whatever its complexity, a single engineer or a single team can do a manual deployment. I mean, they can copy files over, and that's something that's not a big deal. As you start adding new projects, that becomes less and less viable. So that's when the practice of DevOps starts coming to its own, right? And so as you start increasing the number of different domains and different projects and different services you're deploying, DevOps becomes more important. And where platform uniformity and containerization really becomes important is once you start doing this automation, you're going to find that not all services are alike. And so what containerization gets you is uniformity in your deployment strategy. And so deploying a container is deploying a container is deploying a container. They're all the same thing. They're just a process that are running in usually a Linux machine with some additional services and some additional context attached to it. So what containerization actually gets you is that deployment uniformity. Even if your build build is still more specialized on a per service basis, you actually kind of get something for that investment. So establish formal protocols and enshrine them in code. And so as your team start to develop and as you start building out these services, it's going to become more and more important to understand how these services communicate with one another and what are the expectations of that communication. So as you start developing your systems, protocols are going to start to form up. Initially, they're just going to be practices, and they'll become common practices. Then you can say that they're a protocol, and you write them down. So if you know how you're going to handle like the metadata related to a saga, and I will cover sagas a little bit later. Then once that's kind of normalized throughout your organization. You want to make sure that it's formalized within your organization. And so new developers coming online can pick up this documentation and be able to be productive sooner. Because especially because these services are smaller, you can actually see a benefit for onboarding and going from zero to productive for your new developers in a shorter time span. So as I said, DevOps is essential. Automate everything and then automate that. So the less you have to think about a deployment, the better it is. And so developing your company's DevOps practices and maturing that is extremely important when you're dealing with microservices. Plan for security from the start. So this is at the bottom of the page, but is in no way a footnote. You want to make sure that each service is limited to only the access that is required for it to do its job. So if it's don't you don't share connection strings. You make sure your communications between services are encrypted and your network is set up in such a way that it's not going to accept communications outside of its expected endpoints or origin points. So moving on from there, were there any questions, Will?
No questions.
All right. So data everywhere. So your DBA may not be happy, and there's a good reason for this. That there the set of the lore of his people says that redundancy is a bad thing, and there is a central requirement for microservices architecture is that individual databases are isolated from one another entirely and are only updated through events or through domain related tasks. So it's going to take it's going to be some hard conversations and just try and understand their perspective and help as well as you can guide them through this transition. And I think when they really get to it, I think they're going to really start to onboard the utility and the usefulness of these patterns. So just data and microservices. So data. Skipped ahead a little bit. All right. So data and microservices. So like I said, in a microservices architecture, you're going to have an individual database or NoSQL resource dedicated to that microservice. Assuming it even requires storage, you could stand up a microservice that really doesn't. It's just like a signal processor. Signals come in, signals go out, and there's no requirement for storage in between. But here's a pretty common one. It's a somewhat simplified purchasing arrangement. So you have an inventory, a shipping department, shopping cart, an invoicing system, and a pricing system. So something to say about pricing systems and inventory control and all of these. They're all more complicated than they look at first glance. Pricing is never just a product and a price. There are sales concerns to take into account. Bulk pricing. There's corp to corp versus corp to consumer pricing. There's how taxes are calculated. Maybe, well, that's probably not going to be in pricing, but it's definitely going to be an aspect of what your system needs to take into account. So a pricing engine can be a fairly complicated thing, and it changes very quickly. So just every sales cycle can mean a sizable modification in the way your prices are calculated. So what you really don't need all of that complexity to write an invoice. All you need to know is what is the price right now for this quantity of this item. So invoicing itself can be fairly complicated. I mean, there's different if you're dealing with the different report formats, different clients that have different requirements. Government agencies obviously have their own way of about things. So invoicing can be fairly complicated. Inventory control obviously can be very complicated. And so each of these domains, each of these individual microservices are their own little universes, right? And so you want these little universes to be isolated from one another and only interact with light, which is obviously an event that happened in the past because it has a speed. So all of the light you see from the distant star has happened, millions of years or billions of years into the past. Similarly, every event that your microservice sees happened sometime in the past. You never see events from the future. So something to keep in mind as you're dealing with this, and you see that my system is not quite the theoretical perfection that it should be, and so because these things are small and your teams are smart, eventually you're going to make sure that all of these communications are through events. So this actually transitions really well because there's all of these hard conversations you're having with your DBAs, you're going to actually have between your team members as well. So this type of transition can be stressful. Be patient with your peers. Keep your eyes on the goal. So, of course, the best thing about our industry is really working with smart people with extensive and varied backgrounds and professional experience. And similarly, the worst thing about our profession is working with smart people with varied varied industry and working experience and backgrounds. So because everybody has different experiences, some that they build up over the course of their career, and they may have different opinions on how something should be implemented. And try and listen to them, and be open about it and try and just find the best approach for your team. And that is going to change over time. As your teams evolve and as you take on, more and more microservices tasks, your approaches are going to evolve, and so that body of shared knowledge is going to grow. So obviously, different people learn in different ways, and some of your team members are going to read extensively from the literature related to microservices. Some are going to go off of code examples they've seen of a microservice. Some are going to be going off intuitions born from nearly forgotten past experiences, where they tried something or their team tried something and they ran into problems. Some of your peers may be listening to to some good advice from an odd yet charismatic speaker. So because of this, these conversations, especially early in the project, are gonna be time consuming. Plan for that. And don't get hung up on any one decision. The road is long, and you'll have plenty of opportunities to reevaluate. And Sometimes in this situation, like this road here, changing directions is a good thing, right? The initial direction was a good thing as well. So your systems are going to be evolving. These microservices are going to get written and broken apart into smaller microservices, and that's really what you want. You want to evolve the system to meet the needs of your business. As that system evolves, you want to start making it easier and easier for yourself to manage and for your teams to manage. So, any questions on what we covered so far?
Nope, you're in the clear.
All right. So everything is a protocol to someone. And so I mentioned a little bit about starting to formalize your protocols early in the talk. Here's a nice example of it. Alice sends a message to Bob, saying to meet her somewhere. But Eve sees it too and goes to that place. Bob is delayed, and Alice and Eve meet. So this is really the structure of every protocol ever. This is, if you look at the formalization of HTTP, the formalization of any communications protocol, this is the way they're structured. It defines where knowledge is held and where state is held, and how state is transitioned through a system. So this is not only a great way to get a computer scientist to listen to really any boring story. It's a great way to formalize a protocol and a way to document how your organization manages certain types of communications. So keep that in mind as you start to move forward in this and start to formalize what was established practice into something a bit more concrete. So the patterns of today are the protocols of tomorrow. Put some thought into them. Put some thought into patterns that you put in place. Specifically, learn your enterprise integration patterns. So enterprise integration patterns are a really distinct set of patterns from what you're probably used to, the Gang of Four patterns. Gang of Four, kind of specifies a structure, a set of classes, and the way they interact. Enterprise integration patterns are not like that. You can actually implement them in a multitude of different technologies and different programming approaches. So, for example, pipes and filters. You can write pipes and filters in a purely functional manner, where a function is created with a reference to the next function in a chain of that pipe and filter structure, along with an initial call. And so partial application actually can be very useful in this situation. Similarly, object-oriented, a filter could be represented by a class. Another class is passed in that has a next method in which that takes the input type, and that you then just pass on to the next one. And so that could get you could have a class that just works as a pipeline, and that will organize those filter classes into a specific sequence of filters. And heck, if you're a wild man and love Erlang, you can actually implement pipes and filters in a very neat way using the actor model, where you have a coordinating actor that will take the references to individual actors that it spins up, and pass in the IDs for the next steps along the chain. And so each actor calls the next based on that coordinating pipeline actor. So just like that, any of these integration patterns, or the vast majority of them, can actually be implemented on top of pipes and filters. And so I'll cover that a little bit later if we have time. Claim checks, for example. Think about retries, circuit breakers, because failures happen in systems. If your microservice is talking to an external system, you want to make sure that you can incorporate retries into your pipeline. Sagas are your friend if you need to coordinate across multiple microservices for a long-running transaction. For example, that from inventory to shopping cart management to purchase to maybe even reordering if your inventory goes low. So you would use something like a saga to manage that transition. And context is everything. Having your metadata enshrined in a context type that you pass through your pipeline can be very important, and it really can help you implement any of these other integration patterns. Correlation identifiers is one. Correlation ID is something you definitely want to have as part of your metadata, as part of your context. That can actually travel between microservices and act as a way for your sagas to recognize that it's part of the same transaction. So here's a really nice graphic that I've found that kind of shows the relationships between different enterprise integration patterns. And this I actually found this on a website, and I'll have that link up at the end of the presentation. So think of enterprise integration patterns as like a pantry. They represent different ingredients. You can pull them together to build a recipe. So like I said, pipes and filters, and a message router can be implemented on top of pipes and filters, and you can pull in different things to meet the needs of your particular microservice, and even across microservice boundaries. So I mentioned pipes and filters a little bit. And this is really what it looks like. You have something pumping in messages into that, and it goes to filter A, and filter A does whatever it's going to do, and potentially calls a next method or object that's in that chain. And so it's composed together by the pipeline, and a message that's pumped into it will go through each filter until next is not called, which could happen really at any step. And then the filters earlier on in the process are passed back to control until it goes back to the originator. So I've got about 8 minutes left in this presentation. I'd be glad to kind of focus back on any of this. By the way, this is the website that I mentioned. So if you really need to read up on enterprise integration patterns, this is a great resource for you. So since I do have a little time, unless there are some questions.
So there are no questions, but it looks like your timer is slightly off. You have about 5 minutes.
I have 5 minutes. Okay. So in that case, since there are no questions, I have 5 minutes left. I'll go quickly through how one of the enterprise integration patterns can be built on top of this this pipes and filters pattern. So say filter A is going to be a circuit breaker. Your context is going to get hydrated with your metadata related to that circuit breaker, and in this case, it's going to be number of failures, right? And so when that circuit breaker is initially entered, it's going to record a 0 as the number of failures, and then pass on control to filter B. And say filter B could be counting retries, and handle a kind of retry loop that will go maybe three counts, and then pass control back to the circuit breaker. And so what will happen is filter C could be you're calling into your domain, and that may actually trigger some domain events that cause communications with an outside service. If that outside service is down, failure is going to propagate back to your retry. It'll set a timer. After that timer expires, it'll go back to the initial filter C to try it again. And each time it'll increment a counter, and it will wait longer between retries on each one. And so after 3 happens, it'll go back to your circuit breaker, which will, after it's all failed, the circuit breaker will set a timer that will set some global flag for your microservice saying the downstream system is down, don't consume any more messages. And it may send out a message to your external system to alert them of that. So when that timer expires, it'll start consuming messages off of its queue again. Assuming the system is back up, everything will flow through on the first try. The initial failures will get propagated to either a failure queue, depending on your domain, or maybe you'll just get re-queued back into the line to get processed later in time. So that's just kind of a quick overview of how the pipeline can operate within a single microservice, and that can be fairly simple to implement and manage. All right, what's my time look like?
Looking pretty good. Do have one question. It's actually from myself. Do you have any advice on managing? So if the ACL can put events onto your bus that you're able to respond to, so that you can keep your microservice in line with your legacy monolith. Do you have any recommendations on how we can keep those events in line with things like foreign key constraints?
So in that situation, what I've done in the past is to actually stand up a saga that tracks. So you can let your initial kind of frontline microservices deal with checking their key constraints, and they can publish out a message that contains that initial event along with the reasons for its failure. And so in situations where you're just kind of at each point publishing out changes to a single table from your legacy system, that frontline microservice can say, okay, well, what I'm missing an important key constraint here. I need to stand up a saga that's going to wait for that to happen. And whenever that situation is resolved in your microservice, it could do something like either if the timing is reasonable and there's been no other changes to that message, it can republish the initial message, which then can be safely consumed. Can be a fairly complicated implementation, but there are definitely developers that can handle that.
Great, thank you. And we are out of time. Did you have closing remarks?
Nothing other than thank you for listening to me ramble for an hour, and stay classy.
Great, thanks, David. Thank you for sharing, and thank you all for attending Improving's Virtual Lunch and Learn. The recording of this session will be available tomorrow from our virtual events page at improving.com/virtual-events. We hope you enjoy the rest of your afternoon.